is about the influence of aquifer recharge structures and surface water bodies on geogenic fluoride contamination. And you have 6 minutes, please.
Thank you.
Thank you.
Thank you very much. I'm Brindha from the Freie University, Berlin. And in the next few minutes, I'll be talking about work on the influence of aquifer recharge structures in order to mitigate fluoride contamination in groundwater. High fluoride content in groundwater has been reported in many parts of the world. It is a problem, especially in developing countries like India, where groundwater is being pumped and then put into direct use, that is for domestic and drinking purposes. For drinking purposes, fluoride should not exceed 1.5 milligram per liter because it is known to cause human health effects like dental and skeletal fluorosis. For the fluoride, removal methods are usually expensive and they're time consuming. The other problem is the disposal of high fluoride-rich sludge. Hence, in these cases, ISMAR, which has been already used as a suitable option in order to dilute the concentration of many ions in groundwater, that was tested as a method in order to mitigate fluoride contamination in groundwater. This we did, I'll be showing 3 case studies here, which we did in the southern part of India and the state called Tamil Nadu. The study area on top is called as the Pamba River Basin, and the one below is the Vanya River Basin. Fluoride concentrations more than 3 milligrams per liter have been frequently recorded in this area. And the problem is geogenic, the fluoride-rich minerals there, and such as fluoride, fluorapatite, biotite, and hornblende are the main reason for the high fluoride contamination in this area. Thank you. Right. So first, coming to the Pamba River Basin, initially we had to identify the sites that are suitable for ISMAR. We developed a fluoride index for managed aquifer recharge. With the help of 9 surface and subsurface characteristics, we used the overlay analysis tool on a GIS platform, GIS platform, and we found that 30% of this area is suitable for ISMAR. Again, the next step was to identify the exact spot in order to carry out ISMAR in this area. We found that in the southern part, there was a well located close to 2 surface water bodies. These ponds are public ponds, and they have been there for several decades, but they are not maintained, and so the natural recharge has reduced in this area. During the field observations, we found that the groundwater level fluctuation was about 2.5 meters between the pre- and post-monsoon season. And for this 2.5 meters in groundwater level fluctuation, we saw that the fluoride level, which was at an average of 3 milligrams per liter in this well, reduced to about 2 milligrams per liter. So there was a decline in 1 milligram per liter of fluoride. Since these were government-owned ponds, we could not carry out directly our experiments in this area. Initially, we developed a groundwater model for this region, and then we tried after several trial runs, we found that if these ponds had 1 meter of water level throughout the year, except for the summer months, the water level in the well would increase by 5 meters. So that means that the fluoride concentration will be reduced from 3 milligrams per liter to about 1 milligram per liter. So this was one case study which we did, using the already existing surface water bodies as a ISMAR option. The other study which we did was in one of the check dams. In the southern part of the area, there's a check dam that was constructed on a non-perennial river. We wanted to look at the impact and the distance up to which this check dam impacted the water quality. We identified a well close by which always had shallow water level because of the induced recharge from the check dam. And the fluoride concentration was also less than 1.5 milligrams per liter. We wanted to see how much distance these check dams impacted the groundwater quality. And we measured the fluoride concentration and groundwater level from the both banks of the river, and we found that on either side for up to half a kilometer, the water quality was better. The fluoride was within the limits and at potable levels, but then after which the water quality was bad. The fluoride was more than 1.5 milligram per liter. So this was one case study that we did. The other one was in the Vanya River Basin, where we constructed a recharge structure. So it was in one of the low-lying areas. We collected the rainwater, and through a simple infiltration system, we fed this water to a dug well there. And we found that the water level, which was at 14 meters below ground level before the construction of this recharge structure, had actually increased to 9 meters. And also the fluoride concentration, which was at about 3.5 milligrams per liter, had reduced to 1.4 milligram per liter. And again, we wanted to look into the impact of this recharge structure, to which distance it had an impact on the water quality. And as you see from the graph below, we can see that to a distance of about 0.5 kilometers, the water quality was good. But again, after that, the fluoride concentration started to increase. This is a spatial contour figure, and the red dot in the center is actually the recharge structure that was constructed. And this structure had actually benefited an area of about 1 square kilometer. So through this, what we would like to say through these case studies, that MAR can be used as a suitable option to mitigate fluoride contamination. It could be either to existing structures such as the surface water bodies, which could be cleaned up and used, or through the construction of new structures such as the check dams and recharge structures. But they have to be also put into carefully selected sites in order to get maximum benefits. And they should also be upscaled on a large scale in this area in order to mitigate the problem in the entire study area. Thank you.
Thank you, Brindha. Thank you so much. Well, just one question. No questions. Oh, sorry. Oh, sorry.
Just diluting the fluoride concentration in this, because we are using rainwater, the fluoride concentrations are less.
Okay.
Yeah. It doesn't accumulate then? No. We're diluting them.